more about specific implementation. Liam is a data engineer and a data scientist with experience managing software engineering teams in fintech companies, a graduate of MIT, Seoul National University, and the University of London SOAS. Liam has built the infrastructure, services, and machine learning modules that comprise the integrity due diligence platform of the Green Climate Fund's IIU. Liam is responsible for discovering fundamental relationships between financial instruments and integrity risk ratings, the subject of a forthcoming paper. Liam, thank you. Welcome.
Thank you, boss. So I'm going to talk to you today about integrity risk ranking using machine learning. But first, what's the backdrop to our work at the Independent Integrity Unit? Well, we work in climate finance, which is a new area in which integrity risk exposure is quite severe due to complexity. And nobody really has a good set of countermeasures. And at the GCF, we face some challenges which complicate things further. So we have a hard cap on the number of staff that we're allowed to hire across the whole organization, and that affects us in the integrity unit. So we can't hire that many specialists. Although the number increases with each year, it doesn't increase in proportion to the amount of financing that we have issued. A lot of people think we're a UN organization. We're not. Even though we were set up by the UN, we aren't part of the UN, and we report to them, but we don't have the nice little blue passport there that would allow us to go into the field and investigate our own projects, investigate any issues there. So we can't do that. And most importantly, there is a policy context around disclosures, which is material to our work. So if you take money from, let's say, the World Bank, you are committing to provide them with disclosures when you take that money, but the same is not true of the GCF. So we have quite limited visibility into our own investments. And as such, we would benefit from a remote monitoring capability that would help us overcome the workforce constraints that I've just mentioned, and perhaps something that could provide as much visibility into our investments as possible. That would be very attractive to us. Step fourth, machine learning. But before we get into the details of what we've actually done, what is machine learning? In traditional modeling, you put your data and a model into your computer, and your computer gives you some answers. But in machine learning, you put your data and some answers into your computer, and the computer gives you a model. And what's different? You need the answers, at least some answers, at the beginning before you have the model, which means that you need a different set of data to the data you want to make predictions about. However, in some ways, machine learning models are just like other models. They're not automatically good. They don't create value just by existing. So when are they useful? They're useful when you have a decision to take and you want to optimize that decision. And so for us at the IIU, that decision is, which projects do we select for a proactive integrity review? And many of you in this room will know what a PIR is. However, for those of you who don't, a PIR is not an investigation. It is a service offering a bundle of fraud detection methods composed into workflows suitable for development finance institutions with outputs which may improve the overall control environment of the GCF in this case. Now, we have over 750 projects and grants in our portfolio, but we can only do 3 to 4 PIRs per year. So we really want to select the most eligible projects or programs, especially given the fact that we don't have that many countermeasures to choose from, and this is perhaps one viable countermeasure. But why is it a viable countermeasure? Why would you want to do a PIR at all? Well, first of all, PIRs offer a risk reduction or loss control option for compliance risk and reputation risk. So when fraud is detected proactively, it tends to be detected more quickly, which leads to lower losses. And second, PIRs offer the fund the opportunity to benefit from real services. So for example, books and records inspection or asset inspection costs money and takes quite a lot of time and expertise. And PIRs allow the fund to benefit from these services at costs cheaper than in-house provision. And finally, the big one, improved disclosure. So for external stakeholders, improved disclosure on our part at the GCF offers increased transparency, which can help avoid overreaction to bad news on short-term performance because there might be a reason for it. And if risks outside the control of the GCF are hedged, then stakeholders can monitor fund performance better. But this is a decision we take only once or twice a year, and that's why we need to select projects well. How do we do that? We do it by constructing an integrity risk ranking. And that process of constructing a ranking starts with integrity risk rating using some state-of-the-art red flag detection, which we've developed. So we start with around 65,000 GCF documents, and we use those documents as inputs to applications which perform text extraction and natural language processing. And next, we have two machine learning models. The first model predicts whether a sentence is relevant to performance of control obligations, and the second model predicts whether such a sentence indicates non-performance. And here are some examples, both in the public domain, by the way. So in the first example, a contingency budget drawdown request was rejected for a second time. And here the first layer model predicts correctly that the sentence is relevant. And the second layer model predicts correctly that this sentence indicates non-performance. So after human review, it gets a red flag. However, there are not only red flags. In the second example, a procurement was delayed but completed on time. And here the first model predicts correctly that the sentence is relevant, and the second model predicts correctly that the sentence indicates performance. So after human review, it gets a green flag. But how did we calibrate these models, you might be wondering? Well, we at the GCF have a problem as a young institution. We lack a 20 to 30-year-old portfolio of projects for which it can be said that some subset of these projects experience weakness in performance of control obligations, whereas some other subset exhibited adequate performance or strong performance of control obligations. So what can you do in this situation? Well, you can go to an adjacent domain where there is more data. You can train your models there and then transfer those models back to the core domain for use in inference. And that is exactly what we did. We started with the World Bank Projects API using almost 70,000 documents from a relevant subset of projects similar in composition to the GCF portfolio. And then from among those documents, we used audit reports and implementation completion reports to identify and label sentences which offer meaningful statements about performance of control obligations. And there are a couple of examples up here right now. So in the first example, a project was rated satisfactory on safeguards and fiduciary compliance. Throughout its implementation, this is clearly an example of a project that was well run. And in the second example, an auditor was unable to obtain sufficient evidence to issue anything other than a disclaimer of opinion. And this is clearly an example of a red flag. So we labeled about 1,300 sentences in this manner and created what we call the project level control performance data set. Now, most peer officers within the UN system or within MDBs use an approach to project selection for PIRs based on inherent risk factors. And we were able to test this approach using the project level control performance data set, finding it to be weak. And by contrast, our sentence level models perform well enough for use in GCF operations. Specifically, our first model is 94% accurate, and our second model is 93% accurate. And as such, while we have trained our models on World Bank documents, we have now transferred these models for use in inference about GCF-funded activities. The highest standard of transparency in this work is reproducibility. So for technical stakeholders, we offer coding notebooks with explanations. And for all other stakeholders, we offer documentation written in plain English. And you can see some of it on your screen right now. Now, we wouldn't be able to present on risk ranking without showing you a ranking, but unfortunately, almost everything in this ranking is redacted. This is the top 10 riskiest projects by red flags detected from within a subset of our portfolio, from within an instrument called the Readiness and Preparatory Support Program, which is basically capacity building grants. Now, there are 335 grants in the ranking, so it is very, very long, and you're only looking at the top 10. But given our problems with visibility into our portfolio, it's fair to ask, that's all very well and good to have this top 10, but how much visibility has this process actually provided us? Well, it turns out we have quite good visibility, at least when we break down the data by delivery partner. So a delivery partner is someone who helps us administer a grant. And this is one of many sanity checks that we perform on our machine learning to make sure we are checking that our ranking doesn't suffer from any blind spots. So for example, perhaps some delivery partners offer disclosures and some delivery partners don't. Well, it looks like that's not the case, because if we had blind spots in this area, we would see them appear as dots in the top right quadrant. I know it looks like DP8 is potentially a blind spot, but I'll just draw your attention to the x-axis, which is log 10 scale, so our exposure to this particular DP is actually really, really small, whereas our exposure to the DPs in the bottom right is quite a lot larger. So that's delivery partners, but what about countries? Well, it turns out that here, are there any blind spots? No, there are not. This is partly a function of how we allocate our readiness funding in a very uniform way. And these risk rankings allow us to offer a measure of portfolio quality by integrity risk rating and instrument. So this is the format that we report in to the senior management team and to the executive director, but this is of course not GCF data, because there's no way I would be able to show that to you. So what I've done here instead is I've generated some data to approximate the same report. And even though this is not real data, it does show the 6 major instruments in our portfolio. And it does show the most interesting relationship that we found as a result of doing this machine learning, which we did not expect to find, which is that grant portfolio disbursements are much more exposed to high integrity risk than are disbursements for any other instrument. So that's the 2 charts along the bottom, in the middle and on the right. And this result is quite remarkable because our machine learning models knew nothing about which instrument was used for which project or program. Our models were not trained to identify sentences belonging to a grant from sentences belonging to a loan. All the models looked at was sentences without any context as to which project these sentences belong to. If there are any skeptics in the room, how much would it cost for us to do this if we were not using machine learning? Well, we've had to process a lot of documents. So there's actually so many documents that if we in the IIU now started reading these documents, we'd never finish, because the number of documents doubles every year. But how many people would we need to hire? Let's just forget for a second that we have a hard constraint on the number of staff at the GCF. How many people would we need to hire in order to do the same thing as we've been able to do with machine learning? Well, there are 38.6 million sentences, 579 million words of technical and financial documentation. So if anyone knows about average reading speed, normally it's a lot higher than 75 words per minute, but if it's technical document, it's going to be a lot slower. So 75 words per minute is quite reasonable. And if you assume that your staff cost 100K a year, well, the cost of this option, doing it without machine learning, is that you have to hire 81 people in order to read all of the documents, to find all of the red flags that we found using our machine learning. And that would cost you $8.1 million. And like, let's say perhaps you think that you can just pay everyone half what we would pay them and work them like 20% harder. Okay, good luck with that, because it's still going to cost you $3.4 million. And so what did we actually do? We did option B, which is a lot cheaper. And we built what we call the integrity due diligence platform. Thank you.